Thanks for tuning in to our IEEE VR paper presentation entitled "Can I Borrow Your ATM Using Virtual Reality for Simulated In Situ Authentication Research?" Let me go a little back in time. Back in 1967, this is how users authenticated on an ATM. ATMs back then were equipped with a keypad with digits from 0 to 9. 55 years later, nothing really changed. If we go to an ATM in the UK, in the US, in Austria, or in any other country, there is still a keypad, and many users authenticate entering a 4-digit PIN on a physical keypad, which we know from existing research is not secure at all. On the left side, you can see QAuth, a system that makes use of cues on the screen and mid-air gestures or touch gestures for usable and secure authentication. And on the right side, you can see probably one of the most famous examples of eye-gazed authentication on ATMs, where users provide input using their eyes only. Now, while these systems are highly usable and more secure than traditional 4-digit PIN authentication, their evaluation happened in a traditional lab, which means that it remains unclear how results from corresponding user studies apply to a real setting. For example, in the work by Dumphy et al., a key design concern of the study was the recreation of sights, sounds, and experiences that are typically of ATM machine usage. In this work, we aim to enhance the evaluation of novel authentication systems by immersing users into highly realistic authentication scenarios with the long-term goal to transition academic research artifacts into practice. In our study, users' primary task is not to authenticate, but rather to withdraw cash, which is usually the case in the real world. We first implemented 2 baselines which represent the scenario where a user's task is to authenticate only. Then evaluated the same authentication method in situ, which means that the authentication was integrated into an ATM and participants had to go through an entire ATM interaction scenario while using our provided authentication method. We had an additional condition in VR where we placed virtual avatars next to the ATM to investigate the extent to which they impact the user's authentication behavior and performance. As authentication method, we replicated a novel authentication method called color pin, which makes use of a traditional keyboard for usable and secure input. The idea here is that 1 digit is mapped to a character on a keyboard, depending on the color. For example, if a user enters a black 1, they need to press the character U on the keyboard. After 1 input, the characters are randomized, which means the mapping between a digit and a character changed due to security reasons. Here, to enter the digit 2 in red, users would need to press the character K on the keyboard, etc., etc. We discussed the motivation of replicating color pin and provide more details in the paper. From a technical perspective, we used the green screen and Oculus/Meta Quest 2, a few tripods, and a Logitech C920 to partially blend the real-world keyboard into virtuality and to enable participants to provide input on a physical keypad while being in VR. Depending on the proximity of users' hands to the keyboard, we blended in their real hands through the camera feed or their virtual hands through the Quest's hand tracking. This pretty much simulates Oculus/Meta's recently deployed mixed reality pass-through SDK. Now, based on this setup, we aim to understand how a VR-based in situ evaluation impacts the real-world authentication system's usability results and the extent to which the use of VR contributes towards a sense of authentication realism, even in a controlled lab environment. We conducted a within-subject experiment with 20 participants. In the study, participants went through an authentication scenario in 2 different environments, VR and real world, and 3 different contexts, lab, ATM, and ATM public. We measured several common usability measures such as authentication time, error rate, and perceived workload. And we also used the IPQ questionnaire to get insights into participants' sense of presence and being part of such an ATM authentication scenario. We had additional 5-point Likert skill questions and also concluded with a semi-structured interview together with structured interviews after each authentication. There is no evidence of a significant difference between our different settings when it comes to the number of input corrections and input errors. However, our results confirm that input in VR takes longer than in the real world. And more importantly, we noticed an increase in authentication times from the lab to the ATM environments in both reality and virtuality. In both the real and virtual environment, participants' sense of being part of an authentication scenario increased significantly from the lab to the ATM environment. There was no evidence that participants' perceived workload was significantly higher in one of the scenarios. Participants' feeling of being part of a user study was significantly lower in all ATM scenarios compared to our physical lab setting. This means that embedding authentication systems into real scenarios contributes to participants' perceived realism. We noticed in our user study that participants changed their input behavior depending on a scenario. So just the fact that we immersed them into a real ATM scenario made them provide input with one finger only and actually changed their input behavior. And they actually mentioned that they usually use touch typing when interacting with a keyboard, but that this changed based on our environment. We combined in this work traditional user-centered security research with virtual reality. We showed how VR enables researchers to conduct simulated in situ real-world authentication research. But despite the high realism of our study environment using VR, we were not able to elicit specific authentication behavior, such as pin shielding, which has been shown to be a thing in the real world. Our results suggest that the context in which such systems are evaluated impacts the usability research findings. And more importantly, it can change the way in which users authenticate and behave. And even more important is that using VR as a research method complementary to traditional lab studies or field studies opens the door for the community to move usability evaluations on real-world prototype systems out of traditional physical lab settings. In the long run, we hope that this eventually contributes to affordable and more realistic authentication research and to transition those research prototypes into practice. Please read more in the paper about our results and our vision of establishing VR as a complementary research method for human-centered security research. Thanks a lot.